Hey guys and gals, it is Coach Goo back once again with another fun-filled, action-packed, flipped geometry classroom video. And today we're going to be learning about the triangle proportionality theorem as well as proportional parts and parallel lines. So let's look at our main ideas. So first we're going to start off with the triangle proportionality theorem. And what this says is that if a line is parallel to one side of a triangle and it intersects the other two sides, then it divides the sides into segments of proportional length. So look at our figure here, and it's pretty much saying if DE is parallel to AC in our picture, and then it's labeled with these triangles, boom. So these two lines are parallel, then BD over DA is going to be equal to BE over EC. And let me color code this for you to make it a little more clear. So BD, this length, over DA, this length right here, is going to be equal to BE, this length, whoa, that's the same color, BE, this length right here, over EC, this length right here. So also, conversely, the converse of the triangle proportionality theorem, if BD over DA equals BE over EC, then that means that DE is parallel to AC. There you go. And so, if you don't really understand all this, the fancy way they wrote it like this, let me just illustrate, let me paint you a picture. So check this out. Pretty much all this is saying is that if, whoa, that's from class today. Pretty much all this is saying is that if, let's say you have a triangle, okay, you got a triangle right here, bam, there's your triangle. Let's say you have a line. Let's say you got a line going through the triangle, bam, that line is parallel to another side, so like this. Then all they're telling you is that the length right here, this length, so in green, that length over this length right here in purple, bam, is going to be equal to this length right here in the pink, whoa, over this length right here in the red. So this is like, there it is. If you have a line and it's parallel to another side, then the lengths are going to have equal proportions in this format. All right, next up. So let's look at the proportional parts and parallel lines. So if three or more parallel lines intersect two transversals, then they cut off the transversals proportionally. So if AB, this line right here, is parallel to CD, and CD is parallel to EF, then AC over CE equals BD over DF. Yeah! So just like that. And maybe you're like, wow, what does that all mean really? What does that even mean? Well, let me draw you another picture here. So what that is saying is that let's say for instance you have two lines over here, okay? Here's two lines, bam. Oh my goodness, two lines, wow. And then you have three parallel lines going through this. So 1, 2, 3. Let's pretend those are all parallel, okay? Those are all parallel. Now, if there's three parallel lines going through, so I'm going to label it parallel, bam, then that means that this length right here, wham, in the green, over this length right here, in the pink, is going to be equal to this length right here in the red, over what? Over this last one in the bottom right, this purple, bam. So that's what this theorem is saying, is that if you got three parallel lines, then boom, you're gonna have a proportion that looks like this, color coded as such. Let's see this in action, in the works. Let's see how it all works with some examples. So take a look at this first top left box. Okay, wow, we can see that we have two parallel lines, and remember, how does it work? How does it work? Let's just do it with some color coding. Remember, if I have two parallel lines, then the format would go as such. This color, whoa, over the green color, bam, is going to be equal to the red over the pink. Alright, so now I'm just going to plug in stuff over here. Okay, so what's the blue? That's going to be x over, where's the green? That's 36 equals, what's the red though? Oh, the red doesn't tell me, but looky here. We got 55 is the total length here, and 45 is the pink, so what would be the remainder? What would the red part be? It would be 10. If you said that, give yourself a high five. You got it. That's right. It's 10. So 10 over the pink, what's that? 45. Well, looky here. We got a cross product. You guys know how to do this, right? So we're going to use the cross product to find x. So bam, bam. So x times 45 is 45. X, 36 times 10 is 360. And then if I'm going to divide both by 45, 45, x equals 45 is going to be 9 is 8. X equals 8. And there it is. Let's go to the next one. Once again, oh my goodness, looky here. We got two parallel lines in the triangle. Wham. This line's parallel to the side right there. Okay, good. Perfect. That means we can set up another cross product, and let's color code it just in case. So that means my cross product is going to be green over pink. And these colors, guys, are just to show you exactly where I'm getting the numbers from on the triangle, okay? So bam over the red. Alright, so now I'm just going to plug in. Okay, here we go. So the green, oh, that's 30. Over the pink, that's x plus 7. Equals the purple part, that's 25. Over the red part, that's 15. So that's what the triangle proportionality theorem says. Now I'm going to use my cross product property to solve. So 30 times 15 and x plus 7 times 25. 30 times 15 is, you know, actually, guys, I feel like I'm going to make this a little simpler. I'm going to reduce my 25 over 15. I'm going to reduce that. Bam. If I divide 25 by 5, it's 5. And if I divide 15 by 5, it's 3. So this makes it a lot easier. So now it's 30 times 3, which is 90, equals 5 times parentheses x plus 7. Now I have to distribute. Wham. So 90 equals 5x plus 5 times 7, 35. Now I'm going to subtract 35 from both sides. And that's going to be 55 equals 5x. And you guys know the rest. Divide by 5, and then bam, 11 equals x. And we've solved for x. Perfect. Alright, next example on the docket. This is now we're dealing with the proportional parts and parallel lines, but it's pretty much the exact same thing. So look at here, we got 3 parallel lines going through the two lines. So we got 3 parallel ones, like 1, 2, 3. And that means my ratio, my proportion is going to be set up like this. I'm going to do some colors again because it's really easy to see like this. Actually, it's kind of cool. I just thought about this for some reason. So bam, over blue. Okay. So my my proportion is going to be the pink over the green equals what color? What color? What color? What color? Red. That's right. Over what color do you think? Oh, there's only one more color left. The blue. So that's not what I was choosing. Okay. Okay, there it is. Bam. So now I'm just going to plug it in. So pink, that's x, over the green, that's 27, equals the red. Whoa, they didn't tell me, but the total's 32 here, and this blue part's 18. So 32 minus 18, that's 14. Bam. So this red part is 14. 14, and over the blue, that's 18. Now, cross product, cross multiply, bam, bam. 18. Actually, let's simplify. Haha. So 14 over 18, divide both sides by 2. That's going to be 7 over 9. There we go. That's a little better. That means we're going to multiply like that. And this, 9x equals 7 times 27. Didn't get that much easier because I still can't do that in my head. Times 7 is 189. Then divide both sides by 9. And x equals 21. There it is. How easy is that? All right, next up. The last. Is the last? Oh, this is the last one. Would you look at that? Okay. Once again, do I have 3 parallel lines? Yes, I do. 1, 2, 3. Now, that means I can set up a proportion. So, my proportion is going to be what color? What color? Green. Over what color? Pink. Equals What color? Purple. Over. Which part? Which part? The red part. Bam. Alright, so here we go. Let's set it up then. The green is 24. What's the pink? 18. Equals the purple, that's 3x plus 1. Over the red part, that's 12. Now let's reduce this left side. 24, divide that by 6, that's going to be 4. Divide 18 by 6, that's going to be 3. So 4 over 3. Now let's multiply with the cross product. Bam. Bam. So we have 48 equals 3 times, in parentheses, 3x plus 1. Now we're going to distribute the little fingers. Okay. So 48 equals 9x plus 3. Let's move this over here. 48 equals 9x plus 3. Subtract 3 from both sides. What's going to happen next, guys? 45 equals 9x. I want to get the x alone. Divide by 9. Divide by 9. And 5 equals x. Bam! We have solved for x. And that is it, guys. Try the other problems on your own. Okay? Try the other problems on your own. Make sure you understand. But that's going to be the end of this video. And I will see you next time, wonderful children. But until then, peace!